Hello students, today we are going to solve NEET question paper electrochemistry questions, which was held on 8th July 2023. Okay, so here is our first question. A 5 ampere current is passed through a solution of zinc sulfate for 40 minutes. The amount of zinc deposited at the cathode is. So this is basically the question based on Faraday first law. So we all of us know W is equal to E I T divided by 96,500. Now we have to just substitute the values which is given in the question. So they have given the value of I. So I is nothing but 5 ampere, and T they have given in 40 minutes. 40 minutes need to be converted into seconds. Okay. Now we also have to substitute something called E. E here is nothing but the equivalent weight or equivalent mass of zinc. So zinc equivalent mass, how to determine? Because we know the molar mass of zinc. So what is the molar mass of zinc? So molar mass of zinc is equal to, it is 65.38 grams. Okay. Now for the deposition of 1 mole of zinc from zinc sulfate, where in case of zinc sulfate solution, zinc will be in zinc 2 plus, and it will take up 2 electrons in order to convert zinc 2 plus into zinc in the form of solid. So hence it is understood that the equivalent mass of zinc will be 65, that is 65.38 divided by 2. Now substituting this value in this equation, we get basically E value already we have got. Directly we will substitute, where W is equal to 65.38 divided by 2 into I value is given to be 5 amperes into time is given as 40 minutes. So convert 40 minutes into seconds by multiplying it with 60. So divided by 96,500. So if you simplify, all these values, you will be getting a value which is nothing but 4.065 grams. So hence the option D is correct for first question. Now coming to the second question, molar conductivity is lambda m, that is limiting molar conductance at infinite dilution of sodium chloride HCl. Sodium acetate are 126.4, 425.9 and 91.0 Siemens centimeter square mole inverse respectively. Limiting molar conductance for acetic acid will be. So this is basically based on Kohl-Rasch law. So we know the application of Kohl-Rasch law. So Kohl-Rasch law, as part of application of Kohl-Rasch law, we can actually determine molar conductance at infinite dilution of any weak electrolyte. Here CH3COOH is a weak electrolyte whose limiting molar conductance can be determined using molar conductances by taking the molar conductances of the strong electrolytes. Here, in order to get this value, we have to basically require CH3COO minus, that is acetate ion, as well as H plus ion. So basically, from where do we get from acetate and H plus ion? So we can basically get the acetate ion from the limiting molar conductance of the strong electrolyte, which is nothing but CH3COO Na. And to this we need to add limiting molar conductance of HCl. And now basically we don't require sodium and we don't require Cl, that is molar conductances, that is limiting molar conductances that are contributed by Cl as well as sodium. So hence we need to subtract from this limiting molar conductance of NaCl. So now just substituting these values from the given information. So sodium acetate value, they have given it to be 91.0 Limiting molar conductance of HCl, they have given it to be 425.9. And similarly, NaCl value is given it to be, how much is the value? 126.4 Siemens centimeter square per mole. Okay. Now, if you simplify this, we will get a value of 390.5 Siemens centimeter square per mole inverse. So, which option is correct, students? So, option D is correct. Now, coming to the question number 138. The variation of molar conductivity with concentration of an electrolyte X in aqueous solution is shown in the figure. So, what is the figure? So, here we have a plot which is drawn between the molar conductivity on the y-axis and root C on the x-axis, and you can see the curve here. So basically, this type of graph we will get it for weak electrolytes. So hence, from the options, that is the electrolyte X will be from the options we need to pick. So we all of us know that if it is a strong electrolyte, when a graph is plotted between molar conductivity as well as root C, we get a straight line like this, right? So now we are not able to get this line, but rather we have got this, curved line like this, and hence it is understood that this graph can be obtained only for the weak electrolyte, isn't it? Now just check the options. Option A is HCl, where it's a strong electrolyte. Sodium chloride once again is strong electrolyte, and KNO3, that is potassium nitrate, is also a strong electrolyte, and hence option D would be correct for the graph, because acetic acid is said to be a weak electrolyte. So answer is acetic acid. Now coming to 139th question. 2 Faraday of electricity is passed through a solution of copper sulfate. The mass of copper deposited at cathode. Okay, they are giving atomic mass of copper is equal to 63.5 AMU. So first of all, let us take up this copper sulfate solution. Okay, so what is copper sulfate solution? So in case of CuSO4, Cu is in 2 plus oxidation state. So in order to deposit 1 mole of Cu 2 plus 2, 1 mole of solid copper, that is copper solid, we require 2 electrons, which means the 2 moles of electrons, and hence it is also understood that 2 Faraday electric charge, 2 Faraday electric charge is required to deposit 1 copper, that is 1 mole of copper. And we know 1 mole of copper has a molar mass which is equal to 63.5 grams. So this is what is the molar mass. Now in the question, they are actually saying that 2 Faraday of electricity is passed, then how much copper would be deposited at the cathode? So obviously, if 2 Faraday of electricity is passed, there should be deposition of 1 mole of copper, which is equal to 63.5 grams. So hence option D is correct. Now the same question can also be solved with the help of Faraday's first law. So where we know the formula, W is equal to EIT divided by 96,500, and we know what is E value in this case. So E is nothing but 63.5 divided by 2, valence factor is 2, into I value and T value together, they have given it as 2 Faraday. So 2 into 96,500. So divided by, once again, from the formula, you will just substitute 96,500. Now this value gets cancelled, 2 and 2 gets cancelled. So the remaining value is nothing but 63.5 grams. So option D only will be correct for 139th question. Okay, now coming to 140 question. So question number 140. So what is 140, students? Consider the statements S1 and S2. Okay, conductivity always increases with decrease in the concentration of the electrolyte. So basically in statement 1, they're trying to say that conductivity. What is conductivity? So conductivity, we all of us know that conductivity is nothing but K, or specific conductance, isn't it? So what they are trying to say, so K value increases with decrease in concentration of electrolyte. Now, pertaining to decrease in the concentration here, we can also understand this decrease in concentration is nothing but increased dilution. So now K value basically depends upon number of ions per unit volume. Okay, so if unit volume, that is number of ions per unit volume, is increasing, K value will increase. But basically on dilution, okay, on dilution, what will happen? On dilution, the number of ions per unit volume will decrease, and hence K value also should decrease. But then in statement 1, they are telling that conductivity will increase with decrease in the concentration of electrolyte, and hence the first statement is a wrong statement. Now coming to the second statement, students, what is the second statement? So molar conductivity will always increases with decrease in the concentration of the electrolyte. So molar conductance, we all of us know, which is nothing but it is lambda m. So lambda m always increases with decrease in concentration, or how do we decrease the concentration? By increasing dilution. Okay, so hence statement 2 is correct. So which among the following options will be correct then? So statement 1 is wrong and statement 2 is correct. So hence option B would be correct, where S1 is wrong and S2 is correct. Okay. Next, coming to 141, question number 141. So once again, they are giving limiting molar conductance for NaCl, HCl, and sodium salt of some of the acid are 126.4, 425.9, 100.5 Siemens centimeter square ohm inverse respectively. If the conductivity of 0.001 molar HA is 5 into 10 power minus 5 Siemens centimeter inverse, degree of dissociation of HA is. So we all of us know what is degree of dissociation. So basically degree of dissociation is alpha, and we have the formula of alpha to be lambda m divided by lambda m naught. Okay, now substituting these two values, we will be able to determine what is alpha. But basically, if you look at the question, there is no lambda m directly given and there is no limiting molar conductance directly given, which means that lambda m need to be derived from or determined from using the value of K. So lambda m is equal to, we know the relationship, that is K into 1000 by concentration. So the K value is being given in the question. What is the value of K? That is nothing but 5 into 10 power minus 5 into 1000 divided by, what is the concentration given? Concentration is 0.001 molar. So if you simplify this, basically you get the value of 50 Siemens centimeter square mole inverse. Now similarly, in order to determine alpha, now we have got lambda m, and we should determine what is lambda m naught. So which is nothing but limiting molar conductance. So how do we determine? Since they have given the values of the strong electrolytes, that is molar conductance at infinite dilution of strong electrolytes are being given. So for the weak electrolyte HA, we can actually determine limiting molar conductance by Paul-Rush law. Okay. So now lambda m naught of HA can be determined by the summation of lambda m naught of NaA plus, because from NaA you basically get the contribution of A, and similarly you require H, that is H plus. So lambda m naught HCl we will add, and we don't require Cl and then sodium. So subtract lambda m naught of NaCl. Now let us substitute these values. What is the value of NaA? So NaA is nothing but sodium salt of the acid is nothing but 100.5 and HCl value is 425.9 minus NaCl will be 126.4. Now if you simplify this, you get a value of how much? 400. Okay, Siemens centimeter square per mole you will get. Okay, per mole or mole inverse. Now substituting this value as well as this value in the formula, that is alpha is equal to lambda m by lambda infinity, we get the alpha value, which is nothing but 50 divided by 400, and units will get cancelled. So the value will become 0.125. So the dissociation constant is option C. Now coming to 142, question number 142. Resistance of 0.2 molar solution of an electrolyte is 50 ohms. Okay. The specific conductance of the solution is 1.4 Siemens meter inverse. The resistance of 0.5 molar solution of the same electrolyte is 280 ohms. The molar conductivity of 0.5 molar solution of the electrolyte in Siemens meter square mole inverse. So basically this question has three parts. So let us solve how to solve this question. Okay, now actually in this question, there are three parts involved. So which are the three parts, students? Now let us do it one by one. So first thing is that they are giving resistance. So what is R value? R value is 50 ohms and K value they are giving, which is nothing but specific conductance, which is equal to 1.4 Siemens meter inverse. So this can also be written as 1.4 into 10 power minus 2. Okay, Siemens centimeter inverse. So we can write either in centimeter inverse or in terms of meter inverse. Okay, now basing on this value, we can actually determine in the first step, that is nothing but G star. G star is nothing but L by A, which is also called as cell constant. And we have the formula for cell constant where it is the product of K and R. So if you do K and R, we will get, that is 50 into 1.4 into 10 power minus, one second, minus 2. How much is the value? Units. So units is Siemens centimeter inverse, and here you have ohms also. So now when you do multiplication of 50 into 1.4, you get 70 into 10 power minus 2 centimeter inverse. Now ohm and ohm inverse will get cancelled, and you will get basically 70 into 10 power minus 2 centimeter inverse. So this is the first step where you have determined cell constant. Now at the second step, using the cell constant value, we will be determining K value, because they have given the resistance of 0.5 molar solution of the same electrolyte is 280 ohms, and hence K value need to be determined here. So how do we determine K value? So using the cell constant value, because G star is equal to KR. Now if you want to determine K value, how do you get the formula? That is nothing but G star, that is cell constant divided by R. Now we know the value of cell constant, that is 70 into 10 power minus 2 centimeter inverse divided by 280 ohms. Okay. Now on simplification of this, basically you get a value of 0.25 into 10 power minus 2. Ohm inverse will become Siemens and this will become centimeter inverse. This will become centimeter inverse. Now second step is also done. Now the third step. So what is the third step, students? So third step is nothing, the final determination, which is nothing but the molar conductivity. So what is the formula of molar conductivity, students? So we are, all of us know that it is lambda m is equal to K into 1000 divided by C. So now substituting the values. So what is the value of K, students? You have determined it to be here. This can also be taken as 2.5 into 10 power minus 3 Siemens centimeter inverse. Now substitute the value of 2.5 in the place of K. 5 into 10 power minus 3 Siemens centimeter inverse into 1000. So 1000 is actually a liter or 1000 ml, which will be considered to be centimeter cube per liter divided by concentration. So what is the concentration that has been given in the question? So it is nothing but 0.5 mole per liter. Okay. Now if you simplify, you will basically get the value of 5 into here 10 power 3 and uh, here also you will get 10 power 3 and basically centimeter inverse, and here you have centimeter cube. So this and this got cancelled, that is 10 power 3 as well as 10 power minus 3. So this gets cancelled, 1000 and this gets cancelled, and you will get basically 5 centimeter square. You will get what? 5 Siemens centimeter square per mole will be the value. Okay. Now in the question, they are asking us to determine molar conductance in terms of meter inverse, sorry, meter square. So how do we convert? We know the relationship, right? So 1 centimeter is equal to basically 10 power minus 2 meters. Okay. Now substituting this in this equation, we get the value of 5 into 10 power minus 4 Siemens meter square per mole. So which option is correct, students? So option number A is correct for this question. Okay. Now coming to the next question, students. Hope you are understanding. 143. The equivalent conductance of NaCl at concentration C and at infinite dilution are lambda C and lambda infinity, respectively. The correct relationship between lambda C and lambda infinity is given as. So basically, they are asking equivalent conductance at of NaCl, which is nothing but the strong electrolyte, right? So for the strong electrolyte, they are asking what is the relationship between lambda C and lambda infinity. So this is once again a direct question where we know that the graph is drawn between root C, and here it can be lambda m, that is molar conductance, or equivalent conductance can be taken. For strong electrolyte, basically you get a straight line like this. With extrapolating this, you will basically get this value to be molar conductance at infinite dilution, and this is the negative slope. So negative slope means basically which expression would be correct, and this is root C. So on basis of this root C, we can rule out option A cannot be there because we are using C, just concentration. So option A won't be there, option B also will be ruled out. Only among C and D, one of the options will be correct. But then which option is correct? This is the graph, right? So whenever you get a graph like this, you have to know that this graph where the equation also should obey line regression formula. So basing on that, for this equation, if you write the line regression formula, that is y is equal to x is root c, right? So x and hence b constant will become slope, and slope is also negative, and hence this option would be correct, and intercept is limiting molar conductance, that is lambda infinity. So option C would be correct for this question. Option D won't be correct. Why? The slope is shown as positive value. If the slope is shown as a positive value, you don't get a line like this. Rather, you will get a positive, line. So hence option D is wrong. So only option C is correct for 143 question number. Now coming to 144. So consider the following standard electrode potentials in aqueous solutions. Okay, what they are giving? Aluminium and thallium, and whose standard reduction potentials are given for two cases. So aluminium in +3 oxidation state as well as +1 oxidation state, and similarly thallium also +3 and +1 oxidation states. Okay. Based on these data, which of the following statements is correct? So which of the following statements is correct? Okay, let us look into the options. So all the options are dealing with something called stability. Okay, before going into the options, we will try to understand what exactly these standard reduction potential values convey. Okay, now what do we understand in case of aluminium? So aluminium, when it is in +3 oxidation state, it has a high negative standard reduction potential, which is nothing but -1.66. Whereas when it is in assuming monovalent positive charge, it is having positive. See, basing on these two values, it is understood that aluminium would be more stable when it is a 3+ state, and it also becomes good reducing agent when it is become 3+, which means that 3+ is more stable for aluminium. And similarly for thallium, basing on this standard reduction values, we can say thallium plus is more stable when compared to this one. That is thallium 3+. Now, looking into the options. So what are the options, students? So thallium plus is more stable than Al3+. So thallium plus is this, and Al3+ is this. So what is the value of thallium, plus? It is just -0.34, whereas aluminium is -1.66. The one which is having higher negative values will become a very good reducing agent, and hence you won't actually determine that thallium can become more stable than aluminium, isn't it? So hence option A is wrong. And coming to the option B. So what is option B? Al plus is more stable than Al3+. Absolutely wrong. Why absolutely wrong? Based on this values, that is -1.66 and 0.55. 0.55 is the value for aluminium plus. Thus 3+ is -1.66. So basing on this value, we can clearly say that aluminium can easily lose its 3 of electrons, and hence aluminium in 3+ oxidation state would be more stable when compared to aluminium in +1 oxidation state. So hence option B is also wrong. Now coming to option D. So what is option D? So thallium 3+ is more stable than aluminium 3+. See, look at this. Thallium has a positive value, which also indicates that it cannot lose 3 electrons, isn't it? And hence it cannot make only, most positive 3+ oxidation state. In such case, we cannot say that thallium 3+ will be more stable than aluminium 3+. Only aluminium 3+ is highly stable when compared to thallium 3+. So hence option D is also wrong. Now, only possibility that option C becoming correct. So what is our option here? Thallium plus is more stable than Al plus, obviously. Because if you look at the value of M plus of aluminium, it is positive 0.55, whereas here it has a -0.34. So in comparison to aluminium and thallium, thallium can easily lose its one electron and become stable, whereas aluminum will not be able to lose its one electron and become stable because of its positive value. So hence, option C would be correct, which means that thallium plus is more stable than aluminum plus. Hope you understood this question, students. Now coming to 145. So what is 145? The anodic half cell of lead acid battery is recharged using electricity of 0.05 Faraday. The amount of PbSO4 electrolyzed in grams during the process is. So fine. So this is basically understood as PbSO4. Okay. On recharging will be acting as anode. So hence, when it is undergoing, electrolysis, there will be formation of PbO2. So which means that PbSO4 is getting converted to Pb4 plus 2 electrons are involved for the conversion of Pb2 plus to Pb4 plus. So this is what is the reaction that can take place, and which means that we will also be able to understand that 2 electrons are involved in this process, isn't it? Now, they are also trying to ask us that the amount of PbSO4 electrolyzed. So they want this total amount. Okay. So now from this reaction, we can basically understand that 1 mole PbSO4 to get electrolyzed, it requires 2 Faraday electricity, isn't it? Now, they are giving in the question that 0.05 Faraday, and if we are supplying only 0.0 Faraday, how many moles of PbSO4 can be electrolyzed? So this is what is the question, but they want the answer in terms of grams. So now we have to substitute 1 mole is equal to 303 grams. So which means that for 303 grams, this 2 Faraday, means for 0.05 Faraday, how much would be the grams of PbSO4, that is lead sulfate. So this will become the unitary method divided by 2 and into F. Here also you have a Faraday, okay, into 303 grams. Now Faraday and Faraday gets cancelled, and if you simplify this, you get a value of 7.6 grams of PbSO4 that can be electrolyzed when you are supplying 0.05 Faraday. Okay, so which option is correct, students? Option C is correct. Now coming to the next question. What will occur if a block of copper metal is dropped into a beaker containing a solution of 1 molar zinc sulfate solution? Okay, we will now try to understand what will happen if a block of copper metal is dropped. Okay, now let us understand the reaction. We all of us know the reaction which takes place in the galvanic cell or voltaic cell, where zinc, when it is reacting with Cu2 plus, there will be formation of zinc 2 plus Cu solid, right? So this is in aqueous state, this is also in aqueous state, and this is solid, right? So now, when you are taking any solution in which Cu2 plus ions are there, that can basically react with zinc. Why it can react with zinc? Because zinc is undergoing oxidation and copper is undergoing reduction. Okay. So when copper is present in Cu2 plus state, it can actually undergo reduction. But in this case, what is happening? They are taking the copper metal. So when you are taking copper metal, copper is in solid state where oxidation state is 0. Oxidation state is 0. So when its oxidation state is 0, further Cu cannot be subjected to reduction. So hence, what can we expect from this? So we can expect that, okay, first let us read the options. The copper metal will dissolve with evolution of oxygen gas. Obviously not at all possible. The copper metal will dissolve with evolution of hydrogen gas. So there is no hydrogen itself. So hence from where hydrogen will be obtained. So this is also not possible. So option C would be correct. No reaction will occur. Why no reaction will occur? Because copper is taken in directly the metal form where oxidation state of copper is 0. So hence option C would be correct for 146th question, and we will also look into the fourth option. What is it? The copper metal will dissolve and zinc metal will deposit. This will not be possible because zinc is more reactive when compared to copper, because zinc has a value, electrode potential value of minus 0.76 volts, whereas copper will have plus 0.34 volts. So hence option D would be incorrect. So option C only is correct. No reaction will occur. Coming to 147th question, which of the following reactions, which of the following reaction is possible at anode? So question is very clear. So they are trying to ask you among the given reactions, which one can occur at anode? First of all, let us understand at anode what type of reaction takes place. So we all of us know that it is oxidation reaction. Okay, at anode always the metal should lose their electrons and undergo oxidation. Now, among these reactions, we have to find which is undergoing oxidation. So just as simple as this. So now look at the first one. What is happening? 2 moles of Cr3 plus. So oxidation state of chromium is understood that it is 3 plus. When it is made to react with 7 moles of water, there is formation of dichromate. So dichromate only, what is the oxidation state, students? So on the product side, it is clear, right? But on the product side, what is the oxidation state of chromium? So chromium is having 3 plus oxidation state. But in case of Cr2O7 2, that is 2 minus, that is 2 minus 2, 1 second, 2 minus, where each of the chromium, okay, will be having how many oxidation states? Let us take oxygen to be 2 minus. So 2 minus means 7 into 2 minus will become minus 14 and minus 14, and this plus 2 it will become. So it will become, so plus 40 and minus 2 which will become plus 12, and this plus 12 will be divided for 2 chromiums, and each of the chromium will have an oxidation state of plus 6. Okay, now whenever there is increase in the oxidation state, it is understood that the process is oxidation. So plus 3 to plus 6, whenever it is increasing, it is called oxidation. So hence the first option itself, we can make sure that the oxidation is taking place in the option A. So this is correct, but still we will also look into option B and option C. So what is option B? So option B is saying that F2. So F2 will have oxidation state of 0. F2 will have oxidation state of 0, and it will become F minus only when it gains electrons. Only when it gains electrons, and hence this is reduction. So reduction will not take place at anode. So option B is incorrect. Now looking at option C, half mole of O2 when it is reacting with 2H plus, there is formation of H2O. So once again here, oxygen is basically in zero oxidation state. So when it is going from O2 to O is becoming O2 minus. So which means that once again reduction only is happening by gaining of the electrons, and hence option C is also incorrect, and option D can't be there, none of this. So the first reaction only is correct, which is nothing but oxidation reaction. So only oxidation takes place at anode. Hope you understood this question, students. Now coming to 148 question. So what is 148 question, students? So this is once again, okay, let us read. The standard reduction potentials of 4 metals AB, okay, C is missing, AB, CD are minus 1.2 volt, 0.6 volt, 0.85 volts, and minus 0.76 volts respectively. The sequence of deposition of metals on applying potential is. Okay, so here we need to understand there is something called deposition. Okay, so where actually deposition takes place, students? So at anode oxidation, but at cathode reduction, right? So cathode reduction, and on cathode only basically deposition takes place. Okay, so if we carefully understand this question, answer is quite simple. So to become or to undergo a reduction reaction with cathode, the species should have positive values, isn't it? So it is undergoing reduction. So it is undergoing reduction means, so they must be having SRP, that is standard reduction potential values, to be positive. So which means that the species which are having positive standard reduction potentials will actually undergo reduction at cathode, and only then they will be undergoing deposition. Okay, so now basing on that, we will also be able to write the sequence of deposition of the metals. Okay, so the one which is having higher positive. So who is having higher positive value, students? So 0.85 and 0.6. Who is higher positive? 0.85. So who is 0.85? C. So C will be having, uh, the high ability to undergo reduction and get deposition at cathode. Okay, so this is the one. So second positive value would be 0.6. So which means that it is B. So first is what? First is C, followed by B, and among negative values 1.2 and minus 0.76. So hence first you will write minus 0.76, and hence it will become D followed by A. So now which option is correct according to the sequence that we have written? So A, C, B, D. So option C only would be correct for this question. Okay. Now coming to 149, question number 149. So once again they are giving, okay, redox couples they are giving, and then they are also giving the electrode potential values. So here E naught of Cl2 and Cl minus, that is chlorine redox couple, is 1.36 volt. Chromium redox couple minus 0.74, and dichromate here they are giving it to be 1.33, and similarly for manganese, permanganate and manganese ion, they are giving it to be 1.54 volts. The correct order of reducing power of the species. Okay, fine. So reducing power means always what is it? Reducing ability. Reducing ability or becoming reducing agents, or becoming reducing agents. Reducing agents depends on the SRP values. Okay, now when any species can become very powerful reducing agents, only when the SRP is negative. Only when SRP is highly negative. Now coming to that, basing on the values, look at this. Chromium alone is having negative value, and remaining three of them are having positive values, and hence CR, okay, will become highly reducing. CR will become highly reducing. Okay, and followed by CR. First of all, let us write. So CR is high reducing agent. So followed by that, so we have to check the one which is having least, what do you say, positive value. So according to that, here we are having CR3 plus. Okay, so which means that the second one, 1.33. So this is the next value. Then it will become CR3 plus, CR3 plus. And after this, the next value is, that is Cl minus. Okay, that is nothing but Cl minus Cl minus, and least will be manganese 2 plus. Okay, Mn 2 plus. Now this order, which means that this is highly reducing. Chromium is highly reducing than Cr3 plus, than Cl minus, than Mn2 plus. So based on the SRP values, that is standard reduction potential. So which option is correct, students, among this? Option A would be correct for this question. Okay. Now coming to the next question. If the E0 cell for a given reaction has a negative value, which of the following gives the correct relationships for the values of delta G0 and KEQ? Okay, there are three things related here. What are the three things? One is the E0 cell. The second one is the delta G0, that is free energy change, and KEQ is nothing but equilibrium constant. Now, basically, all three of them can be related with each other because we know the formula. What is that formula? So, delta G0 is equal to minus NF E0 cell. So, this is one equation where delta G is related with E0 cell. And similarly, we also know one more equation where it is 2 minus 2.303 RT log Kc. RT log K equilibrium. Okay, so these are the two things. In the question, what they are trying to ask us? So they are trying to ask us what will be the correct relationship for delta G0 and KEQ if the E0 cell is negative value. Now assuming the first equation. So in the first equation, if you assume E0 cell to be negative, then negative of negative, delta G will become positive, right? So if E0 cell is equal to negative, delta G0 will become positive. So if delta G0 is positive, first of all, let us look into options. In whichever the options it is positive. So option A, delta G0 is greater than 0 means obviously it is positive. So option A can be there. And delta G0 is once again greater than 0. So even option B can be there. Whereas C and D can be ruled out. Now coming to A and B, we also have to prove which one is correct. So based on the second relationship, we will try. Now what will happen if delta G is positive? Okay, that is nothing but if E0 cell is negative, if E0 cell is negative, we know that delta G is becoming positive. Yes. Now, in the same way, if delta G is becoming positive, K equilibrium value will become less than 1. Less than 1, isn't it? So, only in that case, only when what do you say, K equilibrium is less than 1, delta G would be positive. Correct? So, which means that for actually for non-spontaneous reactions or endothermic reactions only, K equilibrium value. Okay, what type of reactions? Endothermic or non-spontaneous. We will have delta G0 is equal to positive value and also K equilibrium will be less than 1. So hence, which option is correct, students? So option A will be correct and option B cannot be correct. Because if E0 cell is negative, delta G will become positive. If delta G is positive, they will become endothermic or non-spontaneous reaction. And based on this equation also, it is clear that KEQ will become less than 1. So option A would be correct for this question. Now coming to the next question, students. Zinc can be coated on iron, okay, to produce galvanized iron, but the reverse is not possible. It is because, okay, what are the options given? Zinc is lighter than iron, obviously not. So basing on this, we will not be able to, do electrochemistry problems. Absolutely not correct. Zinc has lower melting point than iron, not at all correct. Zinc has lower negative electrode potential than iron. Obviously, no. Zinc has higher negative electrode potential than iron. Yes, option D is correct. So we have learned that corrosion can be prevented by galvanization or coating of the other metal, especially metals like zinc. So zinc is highly reactive. So zinc is highly reactive than iron. Highly reactive than iron. Why zinc is highly reactive than iron? Because zinc SRP, that is standard reduction potential value, is negative, highly negative when compared to iron. So hence zinc is said to be highly reactive, and it is also called sacrificial, a metal which can actually prevent corrosion and save iron metal. So that is how zinc would be, zinc has higher negative electrode potential than iron, and hence zinc can only be coated but not iron. Okay, so option D will be correct. Now coming to the next question. What is the next question, students? Limiting molar conductivity of ammonium hydroxide. Okay, ammonium hydroxide is basically a weak electrolyte. So limiting molar conductance of ammonium hydroxide we can get it from three substances they have given. Which are the three substances? They are telling it is NH4, Cl, NaOH, and basically NaCl. So these are the three things that they are giving. So we want to get the value for NH4OH. So one ammonium ion we want and one OH minus we want. So basically from where we can get ammonium ion? From ammonium chloride. So ammonium chloride can be added with sodium hydroxide, where sodium hydroxide will be contributing OH. Then we don't want Na contribution of limiting molar conductance by sodium ion as well as chloride ion, and hence NaCl will be subtracted from these two. So we will see in which among the following this NH4Cl molar conductance is added to limiting molar conductance of sodium hydroxide, and from this there is subtraction of limiting molar conductance of NaCl. So which option is correct? So first option won't be correct. Second option also not correct. Third option NH4OH. Oh, how come NH4OH only comes into picture? So this is also incorrect. And option D is correct. NH4Cl, NaOH, because we require NH4 plus ion as well as OH minus ion. And from here, Cl minus and Na plus is removed in the form of NaCl. So hence option D only will be correct. And this is completely based on Gold-Ross law application of determination of limiting molar conductance of weak electrolytes. Then coming to the next question, students. So what is this question? An increase in equivalent conductance of a strong electrolyte, okay, with the dilution is mainly due to, okay, what they are saying? They are saying equivalent conductance of a strong electrolyte, of a strong electrolyte with the dilution. Okay, they are trying to say that equivalent conductance is basically increases with uh, equivalent conductance of a strong electrolyte increases with the, okay, dilution. Absolutely correct statement. Now we should know why it increases. So increases due to increase in the ionic mobility of ions, 100% ionization of electrolyte at normal dilution, increase in both, that is number of ions and ionic mobility of ions, increase in the number of ions. So from this I am clear that option A only is correct. Why option A only is correct means I will come with each of the incorrect options. So option D, increase in the number of ions. So when we are talking about strong electrolyte, at any given concentration, strong electrolyte will be undergoing complete dissociation. Complete dissociation. Even if you increase the dilution, there won't be change in the number of the ions. So the number of ions increase is only applicable to weak electrolytes, not for strong electrolyte, and hence option D is incorrect. Now coming to option C, increase in both, that is number of ions and ionic mobility. Where number of ions will increase? So number of ions will not at all increase in case of strong electrolyte dilution, because the same reason only is applied once again. As strong electrolytes will undergo complete 100% dissociation at any given concentration, dilution is not going to affect the number of ions. So hence option C is also wrong. Now coming to option B. So what is option B? 100% ionization of electrolyte at normal dilution. So obviously this is also not at all applicable for strong electrolyte. So hence option B is also wrong. Now coming to increase in ionic mobility of ions. Yes, this is correct, and we will justify why this is correct. See, basically in case of strong electrolyte, assuming that the solution is concentrated, in concentrated solution, what happens basically? The intermolecular forces of attraction will be high. So when you are taking strong electrolytes and also assuming that the solution is concentrated. The solution is concentrated. So where the forces of attraction, okay, forces of attraction between ions will be high. Okay, will be high. Now, on dilution, what will happen basically? These forces of attraction between ions will be decreasing, and hence they can start moving freely, and hence ionic mobility increases. Ionic mobility increases with dilution. So hence this would be the reason for increase in the equivalent conductance of strong electrolyte with dilution. So option A only is correct. Now coming to 154th question, students. So what is 154? The standard electropotential Z0 values of Al. Once again, 4 different redox couples with 4 different values. Minus 1.66, 0.80 volts, minus 2.93 volts, minus 0.74 volts respectively. The correct decreasing order of reducing power of the metal. So they are asking decreasing order of reducing power. So which one will be having less of the high reducing power to pick the answer. Okay, now we all of us know which one will become good reducing agent according to SRP, that is standard reduction potential. Based on standard reduction potential, the one which is having high negative values. High negative values will become powerful reducing agent. Powerful reducing agents. So which are powerful reducing agents, students? From the given set of redox couples. So the one which is having high negative. Who is having high negative? So here high negative is minus 2.93. So minus 2.93 will corresponds to whom here? So for aluminium, how much it is? For aluminium, it is 1.66. For Ag, it is 0.80. Okay. For potassium, okay, it is 2.9. Okay. For potassium, it is 2.9. So hence, potassium will be highly reducing because its value is 2.93. And after 2.93, who is negative, which is nothing but minus 1.66. Who is minus 1.66? Aluminum. So after K, we will get aluminium. And after aluminium, who is next negative? So this is here chromium. So minus 0.74. So hence, after aluminium, next powerful reducing agent will be Cr, and least will be silver. So now this is the order of reducing power in decreasing order. So K is more reducing, followed by aluminum, followed by chromium, and followed by Ag. So which among the following options is correct, students? Okay, option B is correct. So K is greater than AL is greater than CR is greater than Ag. So option B is correct. Now coming to the next question. So question number 155. 250 ml of waste solution obtained from the workshop of Goldsmith contains 0.1 molar AgNO3 and 0.1 molar AuCl. So AgNO3 is silver nitrate and AuCl is gold chloride, Rm chloride, isn't it? The solution was electrolyzed at 2 volts by passing a current of 1 ampere for 15 minutes. The metals electrodeposited will be, okay? So basically they are giving the value of current. Okay, what is the value of current? Amperes they are giving, and 15 minutes they are giving, and also the concentrations are given. They are giving. So what is the question? Basically 250 ml of the waste solution, this is obtained from the workshop of Goldsmith, contains both of these, gold metal as well as silver metal, and concentrations of those metals are remaining same. And when it is subjected to electrolysis, which metals will get deposited? Now, let us look into the options. Only gold, silver and gold in proportion to their atomic weights, only silver, silver and gold in equal mass proportions. Okay. Now, how do we solve this question? So, this question can be simply solved by checking the SRP values. What do you mean by SRP? So, SRP here is nothing but SRP is nothing but what, students? Standard reduction potential values. So what is the standard reduction potential of silver? So silver is 0.80. Silver is 0.80 volt, whereas gold is 1.69 volts. Okay. Now, according to the concept, when you have two different, metals with two different SRPs, one among this need to become anode, the other one need to become cathode, right? So, who can become anode and cathode among Ag and Au? So, basically, the cathode means there should be reduction taking place. That is reduction. So, for reduction to happen, it should be a good oxidizing agent. So, good oxidizing agent is the one which is having high positive SRP, high positive SRP. Who is having high positive SRP among silver and Au? So, Au only is having high SRP, which means that at cathode, only gold can electro deposit, right? So silver cannot undergo electro deposition because silver's SRP value is less, and hence it has to act as anode. So at anode, what reaction is expected? Oxidation. So oxidation means it has to just use the electrons and it cannot undergo electro deposition, and hence only gold will be electro deposited. So hence option A is correct for question number 155. So with this, we have covered questions from electrochemistry from the NEET question paper. Students, if you have any queries, you can actually contact me and we can also discuss during our classes. However, I hope you have understood all these questions. Thank you, students.